I said even the best fall down sometimes. I said even the best fall down sometimes. It's one of my favorite songs, but it says even the best may fall down sometimes, right? I may feel like I'm the best sometimes, but sometimes we all fall, right? Even when we're at our best. So don't ever give up, because we always have the chance to pick ourselves up, right? Maybe the end of the year, but it's never too late. That's the way I feel about it. Ready? Let's study. All right, so first thing is, we have this equation, and this question is asking us to complete the table, so we got to fill in all these missing x and y coordinates, and we're going to use the table to make a graph, and then we got to state these properties, these important pieces of information here, okay, to the right. All right, so first thing is, when I'm going through this review, these are not the same questions that are on your review, okay? So don't think that I'm doing the same questions. I actually changed the whole review here, so it's a different questions. If you would like a copy of this review, I will post it at the Google Classroom. It will be there at the bottom of the page, okay? All right, so first thing is, you notice there's no numbers on the left. There's no x coordinates, right? So what do I do do I just start filling in some random numbers? You could. Obviously, they have to be somewhere along this x-axis in our graph. You could just pick like one of these and just fill it in. You could say, okay, -1, I'm going to start there and go from there. So 0, 1, 2. You could do that, but that's not necessary. There's an easier way to have a more accurate table. All right, so what I want to do is look at the equation, and I want to know where's the middle of my table. Okay, where do I set it? So what I'm going to do is I'm going to figure out what's the x-intercepts, but I'm going to do that by doing the box. So if I do the box here, x squared in the first box, 5 in the last box, okay? Two numbers that are going to multiply to 5, remember, but then also add up to -6. All right, well, two numbers that multiply to 5 will be 5 times 1, and 5 plus 1 is 6, but it's negative, so they both need to be negative. So -5x, -1x, that's x squared, so I know x times x is x squared. Then fill in the rest. X times -1 is -1x. X times -5 is -5x. Okay, so now my factors are x minus 5, x minus 1. But again, those aren't the x-intercepts. The x-intercepts are the opposite signs. So if that's -5, well then x equals 5 is my first x-intercept, and x equals 1 is my next x-intercept. So I know my vertex is in between those 2 points. So right now, 1 and 5, there's my x-intercepts. Okay, I'm going to go ahead and write that over here in our information. So 5 and 1, actually let's write this as x equals 5 and x equals 1. Okay, so we already found that. Now I know that my vertex is right in the middle of those 2 points. And it's at 3. So that's what I'm going to put right in the middle of my table. Okay, so that's how I decide what goes here. So now I got to fill in the rest. If I'm starting 3 here, that means below it it's 4, 5, 6, and above it it's 2, 1, 0. And then I got to figure out what's the rest here. Okay, so I'm going to take my calculator right now. I'm going to punch in these numbers and then figure out what's the rest of the table. Or I could do it by hand. Okay, so I know that right here, I'm going to plug in 0 here and 0 here. That becomes 0, that becomes 0. So my first number is 5. Okay? And then I'm going to plug in now 1 here, 1 here. 1 squared is 1. Then -6 times 1 is -6. Okay, so I'm doing that kind of really quick here. So I have 1 minus 6 plus 5. 1 minus 6 is -5. Plus 5 is actually 0. Okay? So, and I can just keep going with each number, plug it in, and I'll get the rest of the numbers. Wham! Magic! Look, they all appeared. They're there, right? I went through the rest of the numbers to figure it out. Now, if you want to know how to do this on the TI calculator, come and see me before class or after class during finals week so you can figure out how to do this the really fast way. Okay, so now I need the important information. I know that point in the middle, that's our vertex. Remember we established that 3 in the middle, that's our vertex. So this is our V. I'll just put V there for vertex. I'm going to go ahead and put that on the graph. So right 3, down 4. Okay, and then I want to know my x-intercepts. Well, we already have that. We already figured that out in the beginning by doing the box. And you could actually do that by just having, filling in the numbers and seeing that in the y column, I have 0 and 0, and that's where my x-intercepts will be located. Okay, and I'm just going to go, and remember in this first one I want a perfect graph. So I'm just going to go ahead and draw the rest of the points. So 0, 5. Okay, 1, 0 is already done. 2, negative 3. And then I already have this one, 4, negative 3. And the last one's 6 and 5. Okay, and I'm going to go ahead and draw a nice U. Nice, smooth U, round it out at the bottom. Come on up, and then don't forget your arrows at the top because it goes off forever. All right, so that's what it should look like when you're done. All right, so now let's go over to this side. Now, again, we already figured out what the vertex is. It's at 3 and negative 4. It's that point right there in the middle, right? And we figured that out on the table. Then our line of symmetry is this line that I drew in the beginning, this dashed line that goes right through the middle. And you can see it passes right through 3, which is also the x-coordinate of the vertex. So when you write the line of symmetry, you always start with x equals 3, because that's the equation of the line. Okay, we already said what the x-intercepts were. We can find them by looking at our table. The y column is 0. That's our x-intercept. All I want to know is what's that number. Don't write this, 5, comma 0. I don't need that. We just need what is the number it's crossing at, or where this graph is touching. Now y-intercept. I can look at the graph and see this is where it's touching the y-axis, because that's what a y-intercept is where it touches this line. Okay, it's at 5. Also, if I go here, anywhere I see a 0 in this column, that's where I know the y-intercept is. And you can see it's here. So 0, 5, 5 is my y-intercept. Okay, so I'll just go ahead and put 5. All right, now maximum. Maximum means that our parabola should come up to a top and should stop here. Okay, but this one doesn't do that. It's not like a mountaintop like this, right? Okay, it's actually more like a valley. It's a river. It comes down and then goes back up. So there is no maximum, none, but there is a minimum, a point where it is at the bottom. And that point there, or that value, is negative 4. And I see that by looking at the y-axis. So negative 4. Now domain. Domain, remember, is all your x values. Range is all your y values. So I'm looking at it as what is x as it goes to the left? What is it doing? Does it just go off forever, this graph? Or does it stop at some point? And if you look at this line, it goes up and to the left forever and ever and ever. So negative infinity to the left. And then to the right, positive infinity, because it does the same thing going the other way. So domain, negative infinity, and positive infinity. And remember, we enclose that with parentheses around infinity. And remember, with domain, it's going to be the same with all parabolas, because they all go off to the left and to the right forever. So domain will always be negative infinity, positive infinity, if you can remember that. Now range. Again, we start in the negative direction, just like we did with x. So we're going to go, first we say, what is this graph doing as it goes down? Does it go up forever, or does it stop at some point? And you can see it stops at the same point where we have our minimum, at negative 4. Okay? And then, so that's our first number that we're going to put. Okay? And then we say, what is it doing as it goes up? Well, it keeps going and going and going, it never stops. So, positive infinity is what we use to notate that. So comma, positive infinity. And now remember, it's different when we have a number in our range or domain. We always put a bracket. And then around the infinity, we put parentheses. Okay? That's it for number 1. And remember, this problem is not the one in not the one that's in your review. You're doing a different one. Okay? Okay, number 2. Now we're talking about the vertex, the shape, the direction of a parabola. Now, each of these equations, you'll notice, they're all in vertex form. Vertex form. And the reason it's called that is because we can just look at the equation and it tells us exactly what the vertex is. We don't have to do any math or algebra to figure it out. Okay, so looking at the first one, remember that we look right here inside the parentheses, and that's going to tell us our x-coordinate. Okay, so I'm going to put parentheses here, and you do that for all the vertexes because remember they're all coordinates. They're all x and y coordinates. Okay, so my x-coordinate is going to come from this 3. But remember, if that's positive 3, x is a liar, so it's the opposite, negative 3. And then the outside number does not change its sign. It's always the same. So it's negative 5. Okay? And now the shape of this equation is determined, both the shape and the direction are determined by that number in the front. By this number, the 2 over 3, the 4 here in the letter B, and then also this number, which it doesn't show anything there, but we know it's always a 1. In this case, it's negative 1. So those numbers to tell us both the shape and the direction. Okay, so now for the first one, the shape, this number is less than 1. Okay, it's positive and it's less than 1. If it's less than 1, that means your shape is going to be a wide parabola. It's going to be wider. So it's like as the number gets smaller, all of a sudden it gets wider. But as the number gets bigger or bigger than 1, then it starts to get more and more narrow. Okay, now the shape, as long as that number is positive, we're going up, but if it's negative, we're going down. So in this case, we're going to make a parabola that goes up like this. Okay, so first I graph negative 3, negative 5, left 3, down 5, right here. Okay, now it's a wide parabola that's going up. So I'm going to make it ridiculously wide. Just make it super wide. Okay, wide like this. Okay, just make it really wide. The next question is how many, it says number of x-intercepts. How many? Cuánto x-intercepts, right? So what we're looking at is how many times does this graph touch the x-axis? Well, it touches it here once. And if I extend this all the way out, it touches here 2 times. So that means it has 2 x-intercepts. So it's not asking what are the x-intercepts, what numbers are they, it's just how many are they, okay? Now the next one, the vertex comes from the number inside of the parentheses, but there is no parentheses here. If there isn't, that means we're missing a number, which also means it's 0, okay? It'll always be 0 if there's no parentheses there. But then that number there is still our second value, or our y-coordinate, 3. And remember, that one doesn't change its sign. And we can't change 0 to negative. There's 0 doesn't even have a sign, positive or negative. Now we look at the 4. The 4 is bigger than 1. Remember, if it's bigger, that means it's more narrow. And the direction, well, it's positive again, so that means this is also going up. Okay, so we're going to go to 0, 3. And remember, it's 4, it's narrow, so I'm just going to make it really skinny. Like ridiculously skinny. Make it ridiculously wide or ridiculously skinny. And if it's a normal graph, then just make it like in between those two, okay? Because you're going to get 3 different graphs. One is going to be wide, one is going to be narrow, and one's going to be normal size. Just make sure we can see the difference between the 3, okay? All right, so now, number of x-intercepts. Well, this graph goes up, and the vertex is above the x-axis. It's never going to touch that line, so there are none. There's 0. 0 x-intercepts, okay? Now the second one, remember this is plus 2, so it's what? Negative 2. But remember, does that change? No, it does not, so it's negative 5. Okay? Now what is the shape? Okay? Well, I look at the number in the front, and it's negative 1. And some of you are thinking, oh, well, that's less than 1, right? So that means it's going to be wide? Okay, but here's the deal. You need to ignore, don't pay attention to the negative. Negatives don't matter. Okay? You look at that number, the number is 1. 1 is equal to 1, right? So there's no change at all. So when we look at shape, for any of these, if there's a negative, don't pay attention to it. Treat it like it's a positive number. And actually what we really say is we say take the absolute value of the number, which absolute value makes it always positive. So that would be equal to 1, positive 1, okay? Now the direction, again, it's a negative number, so in this case it goes down. Okay, so now we have -2 and -5, and then this one goes down. And remember, there's no change, so I'm gonna make it wider than this, but skinnier than this one. So I'll make it like that, okay? Now this one starts here and goes down, so it never touches the x-axis. It'll have 0 x-intercepts. Now, let's say that your let's say the graph, the vertex is here, right? And it goes up. Or it goes down, either way, right? If it starts here, at that one point, how many x-intercepts do you have in that case? There's only 1. It only touches the x-axis once. Okay, so if your parabola is only touching it here in one place, whether it's going up or whether it's coming down, remember that's just 1 x-intercept. Okay?